Okay, so we just did one that had to do with quadratic functions. Now we're going to do another one, but this one's going to use a cubic function. So in our example, there is our squares with sides of length x are cut from the corners of a rectangular piece of sheet metal with dimensions of 6 inches and 10 inches. Okay, that's confusing. Let's draw that out. That's usually the first step with things like this, is drawing out a picture to help us visualize. So I have a rectangular sheet metal, dimensions 6 and 10, and I'm cutting out squares of side length x from all the corners. That one kind of looks like a rectangle, but it's okay. Okay. The metal is then folded up to make an open top box. What is the maximum volume of such a box? Well, first of all, how do I calculate volume? Let's just review that. Volume is length times width times height. So I basically want to create a function for my volume all in terms of the same variable. So what's the length here of my box? The length is going to be this distance right here. So that's going to be 10 minus 2x, because I start with 10 at this full distance, but then I have to subtract out this x and this x because we're cutting those sections out and folding them up. Okay. Let's do width next. Width is going to be this distance here. We're going to find that the same way. We're going to see that's 6 minus 2x, because we have the total length of 6, but we have to subtract out those x's. And then finally the height of my box is going to be this distance right here, because that's the section that we're folding up. We're folding up each of those sides to make an open top box. Okay, so then let's combine that all. You get v of x equals 10 minus 2x times 6 minus 2x times x. And then we basically want to find the maximum volume of this. So we want to find when v of x is its largest possible value. So let's graph this so we can visualize when that would happen. So I'm going to use all the same things that we talked about when we were graphing polynomials. First I'm going to find the roots. I have a root at 0, I have a root at 3, and I have a root at 5. I did that because I have a root at 5 because I set 10 minus 2x equals 0. I have a root at 3 because I set 6 minus 2x equals 0, and I have a root at 0 because I set x equal to 0. Each of those has a multiplicity of 1 because all of those exponents are 1 on each of these factors. Okay, then I need to find my leading coefficient and my degree. So I'm going to do 2x times 2x times x from here, here, and here to get 4x cubed. My leading coefficient is 4. My degree is 3. Therefore, my arrows are going to look like this. And I'm going to start tracing my graph up. Since the multiplicity is 1 at each of these, because the exponents on each factor are 1, these are all just going to go straight through. Okay, so I have my graph. And now I need to find when this graph has a maximum value. So because basically my y value here is v of x, this is x. So at what x value is the volume the highest? So you might think we are going to pick something way up here, because that's when it looks like v of x has its highest values. But we have to take into account that this is a box that needs to have a positive volume. So we have to limit the x's that we're looking at to make sure that the length, the width, and the height are all greater than 0. If they weren't greater than 0, then we would have either a length, a width, or a height that was negative, which isn't possible. So when we're dealing with word problems, this is always something that we have to think about, is to make sure each thing like time or distance or whatever, length, width, all of these things are positive. So since 10 minus 2x has to be greater than 0, that means x has to be less than 5. 6 minus 2x is greater than 0, x has to be less than 3. X is greater than 0, x is greater than 0. Okay, so looking at these, when are these three things true? They're true only between this, when x is between 0 and 3. So if x was on this side of the graph, like if we had 5 for x, then this would end up being negative. If we had -5 for x, this would end up being negative. So we can't have any of those be negative. So we can only look at this section between the pink bars for our maximum volume. So clearly the maximum volume is like around this point. How do we find that point? You guys have asked that question a lot. How do we find those points? You can't find those points without a calculator until you're in calculus. So for now, we're going to use a calculator. If you don't remember how to find the maximum or minimum points on your calculator, bring your calculator class and we will review. But if you do, go ahead and plug that in. You should find that that's at point 1.2, 32.8. So therefore the maximum volume of the box is 32.8 inches.